Hi, welcome to this session. In this session, we'll be discussing about how to improve security and observability of Yugabyte database on Kubernetes. Uh, I am Anjul Sahu. I'm a solution architect at InfraCloud. I have around 12 years of experience in databases, DevOps, cloud, and cloud native technologies. Uh, you can reach out to me on Twitter at Anjuls. Um, in this session, we'll be discussing about what is YugabyteDB, what is the architecture, how do we deploy on Kubernetes, uh, and then we will look into some quick introduction to Istio Service Mesh and how we can use Service Mesh to secure Yugabyte database and also the applications which are sitting on Kubernetes. And we will also explore how to basically improve the observability of Yugabyte and applications using Istio Service Mesh. And at the end, we will have some time for question and answers. So, what is Yugabyte DB? So, Yugabyte DB is basically open source database written with C++, and it's can be deployed on various platforms like Kubernetes, public cloud environments, VMs, um, and it is a very high performance database with single digit millisecond latency. Um, Regarding the high availability and resiliency, it can be spread across geographic locations in multiple AZs, and it offers internet scale uh, in the deployments. So by internet scale, I mean you can deploy you can store multi terabyte data per node, and it supports Postgres, SQL, um, and it also supports distributed asset transactions. So if you look into the architecture, it consists of two main components. The one is called tablet servers, and another one is called master servers. So in this, the tablet servers is basically responsible for storing all the data, where data is actually stored as in shards, and that shard is replicated across nodes to provide resiliency and high availability. In the masters, metadata is stored, so and again that is replicated across servers. So when we lose any server, we can reconstruct all the data and continue to serve users without any downtime. So so next is basically how do you deploy on Kubernetes. So in Kubernetes, you can there are various ways to deploy Yugabyte database. It can be deployed across multiple zones within the cloud environment, or it can be deployed into multiple data centers if you are on premise. So you need minimum three masters and three tablet servers to provide high availability, and you can add any number of nodes, and you can horizontally scale your deployment. So in this, basically, the set of nodes which are the tablet servers and the masters, these are called universe, Yugabyte universe in Yugabyte terminology. And then you can have any number of I mean, on top of that, you can have any number of tablet servers where your data will be stored in the in the Kubernetes cluster. And And usually like you deploy all the applications also in the Kubernetes, and you provide the observability layer that we will discuss later in the session. So also, yeah, each of these tablet server and masters are deployed as a stateful set. So we'll discuss about what is service mesh and what is the relevance here. So basically, in when we deploy all these applications and database on Kubernetes cluster, and we tend to use microservice architecture nowadays. So what happens is like a lot of app developers basically when they try to scale their microservices, that become very complex. So each deployment, whatever they write, they require resiliency, secure communication, service identity, and on top of that, they need to implement observability. So if they're doing for every microservice, it becomes a pain, and that's where actually you need a service mesh. So a service mesh can uh, offer you or offer the developer to basically take out the business logic out of their microservice, and separate out the network part, network component, which are like uh, which provides the resiliency features, uh, like service discovery, retries, circuit breaking, health checks, load balancing, rate limiting. And then using service mesh, you can also implement transparent mutual TLS to provide secure communication between services. Um, and using service mesh, we can also we can observe and provide good monitoring capabilities, which can be like using distributed traces. You can have performance matrices for all the microservices without touching the code. We can have advanced traffic controls policies, and all this is done without modifying the uh, microservice code. So by this actually you can the developers can focus on their business logic, and you provide a consistent way of managing the network and monitoring aspect separately. So one of the service mesh is Istio, which is very popular, that we will discuss in this session. So basically, Istio is using Envoy proxy. So Envoy proxy is a high performance proxy written by Lyft, which is again in C++, and it mediates all inbound and outbound traffic for all the services. And typically, you deploy Envoy proxy as a sidecar with your microservice. So what happened is Istio has a control plane where their main components are there, um, and then basically you have a data plane where all the microservices plus proxies deployed. Uh, so in Istio, there is a process called Istio D, which is kind of providing the whole aspects by service, like service discovery, configuration management, certificate management. And then we have Citadel and Galley. So Citadel basically helps in providing end-to-end strong service to service user authentication, identity management, and credential management. So it helps in providing zero trust security that we will discuss in next slide. Um, Also, the Galley helps in providing the configuration management service for Istio. So basically, whenever traffic comes via uh, ingress, it goes and flow via proxy. So you are always communicating from one service to another service via proxy. So this gives a lot of uh, I mean independence for developers, So they can do a lot of traffic management using this kind of setup. So in this session, we'll mainly discuss about the security aspect and the observability aspect, how it helps, how a service mesh helps in Yugabyte DB context. So in this, we will first go through what are the best practices, security best practices that we can do for Yugabyte database. So I have divided this in two scopes. So one is in terms of database. So in database, we can do encryption at rest. Yugabyte supports this by implementing symmetric keys. Um, then we can also we should configure role-based access in the database, and then we should also enable authentication for all the users. And the next thing is service mesh scope. So I mean the encryption in transit, which is in service mesh scope here. So you can obviously implement encryption in transit with Yugabyte offerings, but when you are deploying particularly on Kubernetes, if you use service mesh to implement this, it becomes easier, and also it becomes like a consistent approach. So you can do that for applications as well as database. Um, and also service mesh helps in rotating the certificates by automatically, so we don't need to do it using any other way. And this all such best practices are based on three main things, which is defense in depth, zero trust network, and security by default. So what do I mean by this? So defense in depth means how do you integrate this with existing security systems to provide a multiple layer of defense. um, and then zero trust network basically helps you build security solutions on distrusted network. And security by default means you don't need to change your application code and infrastructure to implement security. Now we will look into in how do you basically implement mutual TLS or using Istio on Yugabyte database. So in this, we basically like we when we install Yugabyte database, we should use this particular setting to uh, allow Istio to work. So Istio compatibility should be set to true. And then once that is there, you can create the peer authentication policies and destination rules. So this will there you can define the mutual TLS settings. Once this is done, this is actually applied on the whole namespace where the Yugabyte database is running. So it will be applied for all the components which are deployed under that namespace. It includes the tablet servers, the masters, and any other application or add-ons that you are running in that namespace. Um, we also need to create the destination rules for the tablet server and the master server. So by destination rule, I mean we that helps in basically defining the policy that apply to the traffic that is coming to the service after routing has occurred via the proxy. So in this case, proxy is the envoy proxy. So and by Istio mutual, what I mean is that it basically provides a way secure connection. So what happens is that when client connects to the master or the tablet server, the certificates are automatically presented. Next is observability. So in observability, Yugabyte already provide the dashboards which gives you information about the tablet servers and their settings, and then I mean how much IO they are using, how much RAM it is using, etc. But this is like not this can be improved further by using Istio's observability stack. So Istio provides a very rich ecosystem of observability tools like Kiali, Jaeger for distributed tracing, and Prometheus and Grafana for storing the matrices. So using this, all this is combined and available via Kiali uh, project. So in Kiali, you can see all the services which are running in your Kubernetes cluster, and with that you can actually you can also see the traffic. You can also manage the Istio policies. You can manage mutual TLS as well, and you can also do you can also monitor the logs and traces. So we'll see that in next few slides. So this is the UI of the Kiali, where you can actually see all the services that are running under the Yugabyte namespace, and you can observe the uh, security aspect. So if you see this, there is a mutual TLS enabled here. You can also notice the connectivity, how each service is talking to the another one, and what's the rate at which the transactions are requests are flowing. So currently it can observe HTTP and TCP traffic both. So next is a detailed view of a service. In this case, we are looking into the tablet server, how much traffic is coming, and what's the configuration of the tablet server, and whether it is healthy or not. In this, we are able to see logs of the services in the single, in the same dashboard. We can also observe the inbound and outbound traffic, and as well as the traces. So currently it supports HTTP based traces. So once you deploy the application, you can if it's a HTTP based application, you can actually observe how that application is talking to database, and how they are talking to each other. Uh, it also comes with the Prometheus Grafana stack. So currently in this demo, I'm showing the Histo Workflow dashboard, where we can see for each service uh, what are the matrices like incoming traffic, outgoing traffic, how much duration a request is taking, etc. But what I want to tell you here is that Yugabyte also provides or all the matrices through Prometheus. So uh, basically, we can integrate the Prometheus matrices from the Yugabyte into this, and we can provide a single pane of glass view of matrices which are exposed by Yugabyte, and as well as the service mesh. Now the next thing is uh, how do you basically extend the monitoring capabilities of this database by using Envoy filters. So Envoy recently had created filters for Postgres, and there are various other filters on top of network. So in this, basically, we will discuss about the Postgres, which is relevant to Yugabyte database. So what happens is Istio comes with the Envoy proxy, and Envoy implements Envoy filters. which you can use to provide sniffing capabilities. So when the traffic is coming inside the Yugabyte service via the Envoy proxy, you can put filters. So filters are like a small. You can think like it's a small Unix utility, which is chained to provide some kind of output or filtration. So think like it is like a Unix pipe. So when the proxy listens the uh, inputs, it filters down and find out the Postgres relevant matrices, uh, which are then actually then the packet is transported to the endpoint. So in this case, endpoint will be the um, tablet server or the master server. So the main benefit of using this kind of mechanism is it doesn't put any load on the database. It is a very transparent to database how you are extracting these um matrices out of the packet, and currently it is experimental and it's under active development, so things might change. But it is providing a very interesting um, way of basically observing your database. So in this basically I'm just giving one example like how you can implement this. So once you in the Yugabyte sorry in the service mesh, you need to create an envoy filter. Envoy filter should define the it is of type of Postgres proxy. Once you define that, and once you also need to annotate the sidecars, sorry, annotate the services that the you need to basically tell that this is the Postgres matrices. And then once you do that, you can see on the left hand side where I'm basically just reading the envoy proxy matrices. So you will see the all the Postgres related matrices are coming, which can then can be charted into the Prometheus. So once this is done, you can create a singular database where sorry singular dashboard where you can get the matrices from the envoy filter. You can get the matrices from the Yugabyte exposed matrices, and also from the service mesh to provide a very useful and unique, not unique, I mean very useful uh, dashboard that will improve the observability of this deployment. So that's it. If you have any questions, please let me know. Thank you.